Hi, everyone. I'm Roy Chua, principal at AvidThink, a research and analysis company. And I would like to welcome you to the Open Networking Foundation's 5G Transformation with Open Source event. In today's session, I will be joined by Yiannis Yiakoumis, who is co-founder and CEO of Selfie Networks. And what Yiannis is going to be talking about is an interesting topic. He's going to be talking about the use of network tokens as an alternative to DPI in today's network services. With the rise of 5G, and even with today's more crowded networks, and we're all working from home, so we understand what it's like, it's even more important that we're able to provide different quality of services for different applications. For instance, your Zoom or WebEx or GoToMeeting alike, you probably want that to have improved quality of service over perhaps your teenagers' games and or whatever else they may be downloading from the web. And so the concept of differentiated services, the concept of being able to provide different quality of service is an important one. And there's many different ways of doing it. And one of the most expensive ways, in fact, is DPI or deep packet inspection. What Yiannis is going to be talking about is an alternative to that. And so with that, I'd like to go ahead and present Yiannis. Yiannis, take it away.
Thanks a lot, Roy, for the introduction. Very excited to join ONF Spotlight Series and talk about what we do with network tokens and ONF lately. A little bit of background on myself. I'm one of the co-founders and the CEO of Selfie Networks. I've done my research while I was doing PhD at Stanford on similar topics, and as part of providers with hundreds of millions of users trying to do telco integrations worldwide around Zerorating and DPI. So I felt the pain and, the challenges and much of what you will hear here come from this experience. This is joint work with Nick McKeown from Stanford, who was we worked together on some of the original ideas on network tokens, and Frode Sorensen from the Norwegian Communication Authority, who was the tech lead for the European Union's net neutrality framework. So collectively, as a group, we've been thinking a lot about the intersection and the interplay between application providers, mobile operators, regulators, and what I want to share is our insights and what we think is a good way forward to tackle some of the big challenges. I'm going to talk about three things. First, I want to explain why I think network traffic differentiation is at a tipping point, and how DPI is a challenge for essentially untapping all the potential, and why we need an alternative for DPI. And then lastly, I'm going to talk about network tokens, how they work, and what's the promise that that comes with them, and what we do related with this. So we've been, you mentioned the current lockdown, Roy, but in practice, we've been doing network traffic differentiation. We've been talking about network traffic differentiation forever. The holy grail from 1990 to 2010 has been bandwidth, or what we used to call fast lanes, right? And the promise was that you could get a fast lane for video or for another application. But in reality, what happened was that there was no demand. Networks were over provisioned. We had more bandwidth than what we needed. So we never really get to have a commercially successful differentiation service around bandwidth. And between 2010 and 2020, over the last decade, there is something very interesting happening. WhatsApp and Facebook in particularly, they were looking to grow in emerging markets. And what they figure out pretty quickly is that people do not have Wi-Fi, they just have mobile data, and most of the time we're running out of balance. So this was blocking their growth, and what they did is they went to all these telcos and said, hey, let's work together to make our data free or cheaper so that people start using the internet and they get familiar, and then we can find ways to monetize this. And you can familiarize your users with the internet, and this will be a plus for you down the road. Around the same time, Spotify and Netflix had similar issues in developed markets. So if you were to stream 1 hour of Netflix, it will burn all your monthly data allowance. So we had similar partnerships taking place all over the world. And this whole concept of zero rating and application-specific data plans came up. There is like a market of 2 billion, around roughly $2 billion today across the world. And I think what Zerorating did is two very important things. The first one is it validated the market. It showed that there is an opportunity for telcos to differentiate how the forward packets and work with application developers in order to improve the user experience and monetize these services. And it also pushed the ecosystem to come up with a regulatory framework that allows some of this to happen under what we call net neutrality regulation. The other thing that it did is that it demonstrated that technology sucks. And I'm going to talk a little bit more about what I mean here, but essentially all these integrations end up being an operational nightmare for everyone who is involved, and they have serious limitations and are in conflict with privacy and net neutrality compliance. And so today we are at this inflection point as we are transitioning into 5G. So on the one hand, there is all the excitement around 5G slicing and custom SLAs tailored for the needs of individuals or verticals, entertainment, enterprise, IoT, etc. GSMA puts this into a $300 billion opportunity, the whole slicing approach. And we have the necessary ingredients for business growth, right? The desire is there, the understanding of how these services could work is there. But at the same time, the technology is even less suited to go and support this market growth. Two reasons for that. One is the more entities that participate in these sort of like partnerships and integrations, the operational overhead becomes even worse. And the other thing, which I think is like, what signifies that we're going towards like a change in paradigm, is that the Googles and Apples of the world and the Cloudflares of the world essentially are getting encryption and privacy to the next level. So all traffic is getting opaque to the network, and all this concept of like DPI is not going to work anymore. And so we are developing network tokens as a way to tackle these opportunity and essentially enable operators to drive this differentiation and improve user experience. There are essentially, when we are thinking about how telcos differentiate today and how networks differentiate today, there are like two main tools that we use. One are low-level mechanisms like QCI and 5GI and dedicated bearers and deep serve, and these are good, but they are low-level, right? And the main thing that they achieve is like on a hop-by-hop basis, there is a way to tell to the network, hey, like just send this packet through that queue. But the actual policy and enforcement of this policy happens at a higher level, right? And this essentially is being implemented through traffic classification, also known as deep packet inspection. And the main idea here is to create signatures to detect certain applications so that you can drive this differentiation in the network and then use the lower level mechanisms like QCI and deep serve to enforce them. There are three main problems that come with this. One is that the onboarding is hard and it comes with poor adoption by partners. It's very expensive and has high overhead for everyone involved. And when you look down at how it is implemented, it's directly in conflict with encryption, with privacy and net neutrality, because essentially you have to look into a user's traffic, understand what applications they're using, and having this awareness essentially means that type of applications can participate in these type of offerings. We've worked over the last 2 years in driving these integrations or like monitoring these integrations. I've personally been involved in more than 100 of them, where the application and the telco agreed in advance that they want to make this to succeed. And 8 out of 10 times, the integration failed because of the technicalities and how hard it was like to pull things off in a good and accurate way. And when it succeeds, the onboarding time was 9 months plus. And so what happens here is that essentially each of these services, each of these like custom SLAs can be a 100 million opportunity for a telco. But when you expose this through DPI, it means that you have poor user and partner adoption, high cost and time to market to deploy and operate, regulatory risk to be banned or restricted from like, how you comply with privacy and neutrality regulation. And these are getting obsolete with new encryption schemes around encrypted SNI, DNS over HTTPS, etc. And so this got us thinking a lot of how can we do any better? If we agree that we believe that this traffic differentiation can be beneficial for the user, how can we expose and access it in a way that is easy for operators to deploy and operate, easy for end users and application providers to access. It works well with privacy and the net neutrality frameworks in different regions. And it also supports encryption and modern infrastructure from what we see developers using today. And the main insight that we developed is that the conventional wisdom in networking has always said, when you do this type of services, do not touch the endpoints. Do not assume that the endpoints are like coordinating in this process, right? And so this led to all this traffic classification and DPI approach where the network had to outsmart the endpoints about what is happening. And we just see that this is not practical anymore, right? It doesn't work anymore. The endpoints are like the applications are becoming very complex. They are like making their traffic opaque, and for very good reasons, all of them. And so the other thing that happened is that application developers are very much used now to integrate capabilities and workflows through APIs from many different like third-party entities, right? And we think that the network can be one of these entities, right? And so we started thinking about, okay, how do you flip this? And instead of doing traffic classification, we started thinking about this as an access management problem, right? And access management is an interesting paradigm here, because essentially what we have is protected network services that might be charged differently or might be sort of like have different like permission levels, etc. And all we care about is that the people that have the right to access them can access them, right? So we started thinking about these, and the paradigm is very, very similar with what we see at web services with the ID and access management industry, right? So companies like Okta and frameworks like single sign-on and open authorization are essentially giving these essential tools to manage access management. So network tokens essentially are the baseline mechanism on how we can flip all this paradigm on its head and create an API that becomes very, very easy to expose and access. So network tokens are providing a means for an explicit and secure coordination between end users and applications on the one side and the network on the other side. And they replace heuristics and application signatures with the deterministic mechanisms on how to do these type of integrations. And the whole design, as I mentioned, has been heavily influenced by ideas from JSON Web Tokens, access tokens, open authorization workflows, etc. Some of the audience is curious about how this works in practice. I'll try to give a high-level idea without going too much into technical details. So tokens carry simple claims. For example, a token might say, hey, I need low latency, or hey, I'm Skype. And they can be encrypted or signed based on the trust relationships and the requirements of the use cases under considerations. They have provisions against replay and spoofing attacks so that we do not have fraud or abuse of tokens, and we use standard mechanisms to do that. They can be represented as JSON Web Tokens or binary tokens or in their own custom formats, and they are inserted as extensions and attributes in existing protocols. And many protocols have like the capability to add extensions to add this type of functionality, and this is one of the things that we are like heavily working on these days. Now, one important thing to note is that tokens are essentially policy agnostic. The policy is not dictated by the token itself, but by who gets access to these tokens, what are the cryptographic functions that are applied to them, what are the content of the tokens, and finally the end-to-end workflows that essentially demonstrate how can somebody get and use a token. We can have different types of tokens, but there are two of them that seem to be quite applicable in most of the examples that we've seen so far. One is a user-centric application agnostic token, which seems to be a very good fit for QoS services and like SLAs that are around latency and bandwidth, etc. And the other one is an application-specific token, which can be very well fit for a firewall whitelist or a zero-rating example, which is typically application-specific. I mentioned end-to-end workflows as one of the things that dictate policy. And so I want to sort of like, walk through two examples to show you how this works in practice and what is like the end user experience and the application experience. So first, I'm going to show you like a workflow where we have a network, a mobile operator that offers a premium quality service. We have an application provider that wants to use this premium quality service to improve the experience. And we have a user that is subscribed both to the operator and the application provider and becomes the main driver of like mapping the premium network quality and this application together. And the process is fairly straightforward. So it starts by the application asking user permission to access the premium network quality service. And this can happen in a very similar way that an application is asking access for the camera of a user or the location of a user. Once the user gives this permission, then an agent on the client goes and fetches these tokens from the premium network quality service with the user's credentials. The application developer gets access to these tokens. They can attach these tokens to their flows of interest based on what they think should benefit from this service. And then the network detects these tokens and provides the desired service, right? And I think the important thing to keep here is that the whole workflow is extremely familiar. We have it for many other utilities, for camera, for location. Users are aware of these permissions, etc. And what we need to do is just like, bring the network capabilities in par with the other capabilities that users are exercising today. I want to show you like a very similar demo in practice on how it works. And this is something that we've been implementing with the Open Networking Foundation. We've integrated network tokens capability in ONF's mobile core. And so what I'm going to do for a moment is share my screen. What you see here on the top left is an application that it's called GT. And GT is an open source video conferencing application built on top of WebRTC. So what we did is we implemented tokens on top of OMEC at ONF, and we exposed APIs for application developers to go and get these tokens and add them into their service. And so here we did this for GT. We patched GT. GT has this standard video conferencing application. And the way it's exposed to users is through settings. So users can go into their settings and say, I want to enable premium network quality. And this could be as part of their work because they want to make sure that their calls are having like a guaranteed experience, etc. So the moment the user does that, essentially the client goes and fetches these tokens to the operator. And what happens is something that we are all very familiar with. The operator, essentially in that case, it's ONF, says, hey, Yiannis, there is this application called GT that is requesting access to your account, right? And ONF here is the operator. Do you want to give them access to these premium network services? And so all the user has to do is essentially accept this. And from that point on, the developer has access to a token that it's tied to this user, and they can use it for their premium quality services, right? And again, very simple. The main idea is that these are workflows that we already know, users know how to use them, and developers know how to integrate this type of functionality in their networks. So I want to go back a little bit into DPI and compare how the world operates today and what we see the opportunity with tokens. So if you look at the networks and how DPI works, the main idea is that we know how to detect traffic, and this is application specific. So there are these proprietary app signatures. And if you look at the available vendors today, they are comparing how many signatures do I have. I have like 500, I can detect like 1,000 applications, and it's like a never-ending game. And every new application comes with extra cost and extra time to be detected. So these are boxes that are like bloated, both in terms of performance and cost, just because they have like the very manual process of reverse engineering applications and coming up with these signatures. Now, in practice, even when you have a signature, this is not enough. And it's not enough because an application is changing their IP address or adds new servers, so they have to let the network know. And you want to do this in an accurate way. So what happens in practice is that people, application providers work with network operators to make sure that these signatures remain in sync. So you have a very manual, expensive, error-prone process, which is like mostly human-driven, and people are literally exchanging Word documents with IP addresses, and they have to give like months notice in advance because before they change their infrastructure. And the last problem is that everything is application centric, right? So for the network to provide this service, they need to know the application that you're using, and it's not driven by user control. So if you go in places like Europe where QoS needs to be user centric because of the regulation, this poses a very important limitation. How the world is changing when we start thinking about tokens. Three big changes. The first one comes down to the data plane, right? So the data plane essentially becomes very simple and very stable because it doesn't change with every new application. Everything is a token. So the only capability that the data path needs is the capability to detect and verify tokens, right? That's the only thing it needs. New applications is just a new token. And it's the exact same way for the network to interpret this thing. Now, the control plane is also very interesting. We already know how to deal with token distribution in a largely automated and self-serve control logic, right? So all the manual interactions need not be there. We can go into a scenario where like everything is much more automated and has less overhead than what it has today. And the last piece is that the policy itself is just a matter of who gets the token and what are the contents of this token. So with 5 lines of code, you can make a user-centric service or an application-specific service or an application-agnostic service. You can very, very flexibly change the policy and what you want to have. And this is important because the use cases are different. Different countries have different regulators, and operators, like many of the large operators, exist and operate in different frameworks. One note that I wanted to do around standardization and open source and what is the status. All the code around network tokens is open sourced. It's under an Apache license. And you can essentially try network tokens both in a standalone way or in an integrated way, integrated within a packet gateway. We have integrated with Open Networking's Foundation Mobile Core, and we are sort of like are currently doing work in progress to combine these with dedicated barriers and have full QoS support using tokens and existing mechanisms in cellular networks. Network tokens is a proposed IETF standard, and essentially the standardization tries to build these standard, well-defined mechanism between networks on the one side and applications and end users on the other side. In terms of 3GPP, which is a question that that many people are asking, and how tokens fit in the 3GPP architecture, essentially they use the existing 4G and 5G interfaces around traffic detection functions. So ZY, GW, USD. There are some benefit by making tokens further ingrained into the concept of a packet filter across the 3GPP architecture, but we think that like there is a very, very solid starting place that can address many use cases. So one thing that I want to do is like step back a little bit as I'm getting closer to the presentation and talk about the ecosystem that we've seen build around an access management solution. And I want to start with the ID access management industry and how it worked for web services. And I think this is like, something that most people can relate and can see. And, the equivalents for networking are pretty straightforward. So if we look at the IAM industry, essentially there is a low-level mechanism built around JSON Web Tokens, ID and access tokens that can carry trust, right? And on top of these, there are workflows like single sign-on, open authorization, scopes and permissions that define specific use cases on what are like these trust relationships and how the whole process is working. This is taking place out in the open, in open source and in standards, and it helps everyone in the ecosystem to add these in their own workflows, right? And on top of that, there are solutions, both open source and proprietary by companies like Okta, Auth0, IBM, and Microsoft that help the operators add these into their capability and seamlessly integrate them in workflows. So we expect a very, very similar transition in networking to happen and a very similar stack and ecosystem to evolve. Network tokens are essentially the low-level mechanism that carries this trust and has all the necessary ingredients to prevent abuse. We expect workflows like user-centric workflows, application-centric workflows, custom workflows or multi-network workflows to evolve and be standardized down the road and have multiple different implementations. And of course, we expect a multitude of solutions that help operators expose these services to APIs and developers. My company, Selfie Networks, is building one such solution, but we believe that like many other vendors will come and join. And with that, I'd like to close with like an open call for participation. We very welcome like everyone in the community to come and work with us. This is a big movement that needs to happen to move things forward. All the material is available at networktokens.org. There is a mailing list for discussion. The code is available and you can try it today using ONF's infrastructure. And with that, Roy, back to you. If you have any comments or follow-up questions, happy to discuss.
Yep, sure. No, thank you, Yiannis. That was an excellent presentation. And as someone who used to be in the world of IAM, started the company in access control, I like the use of the same kind of mechanisms that we had with OAuth, SAML assertions and the like, and using the same kind of tokens all the way back to the old Kerberos framework in terms of granting tokens and using those tokens to get, in that case, access control, but in this case, differentiated services. So I think very elegant approach to it. So I think that's really cool. Question for you in terms of how you see the adoption now. Certainly, the applications themselves don't necessarily need to be modified, but the OS that they're running on potentially has to be, right? So because you have to insert it into the stack at some point. Mm-hmm. How do you envision seeing that happening, right? Are you going to try to leverage it? You're going to put in an alternate stack? You're going to leverage VPN type mechanisms to insert yourself into existing OSs? Mm-hmm. What's sort of your entry point in that situation?
Yes, so I think there are ways to do this like at the application level. So for example, in the example that I showed earlier, this is like at the application level, no operating system changes, no VPN in place, etc. Obviously, if you do things at the operating system, I think it opens up the opportunities. It removes the burden for application developers on what changes they want to do, etc. So I think it's something, and we believe that the operating system definitely can play a very significant role. And the discussion that takes place at ONF involves OS vendors and the things that they want to see. I think from an OS perspective is a very interesting value proposition, because the OS essentially acts on behalf of the user to do certain things around permissions and privacy, etc. Mm-hmm. And we feel that there is a problem today. On the one, there is this desire from the network that, hey, we have these capabilities, we want to expose them, and the OS saying, okay, how can I do this in a way that doesn't sacrifice my undermines my stance on privacy, etc. And so we think this is one more tool on an effort to make things better for user. So you have deeper encryption, but at the same time, you need to maintain a way to talk with the network. So we see this as something that is aligned with what OS system want to go. But again, right now, we think, like there are many, like it's an adoption period. We're building like the APIs, the client support. We're looking at ways to do this directly from the application, as the demo I showed before. We're looking at ways to work with operating system providers to make these like part of the operating system.
Yeah, no, I see that. The advantage you have is you have a sort of incremental approach that you can take, right? Just same with when OAuth and SAML was adopted. A couple of endpoints first, you start out, and then you get one adoption, two adoption, and then overall it becomes more or less a standard. So that's pretty cool. Do you get questions about net neutrality at all?
Yeah, of course. It's the elephant in the room, right? So yeah. I think the whole concept of net neutrality, and all like the controversy around traffic differentiation is something that comes up a lot. One of the co-authors and conspirators on this work is Frode, who was essentially the tech lead for net neutrality in Europe. So a lot of like the design and thinking has been on how can we do this in a way that it's compliant with net neutrality. So, despite the controversy that you hear at the media, there is very, very specific common ground and consensus on certain use cases. So if you look at QoS, everyone agrees that like if you have a user-centric, application-agnostic, privacy-aware means to do QoS, that's fine with everyone, right? And a lot of like the thinking around network tokens is how can we do this? Like how can we just like address these three requirements, to start with? If you look at Zerorating, where like many countries like are gravitating towards is this category-based inclusive money-free agreement. This is what happens in Europe. This is what California is also, going through their like net neutrality, approach. Not clear what will happen in the US, but we see this as like something that that gets more agreement across the board. And again, tokens can be very good to essentially go from something which is category based but only works for the 5 big providers of like a category to something that can easily accommodate like 200 to 300 providers on that same category. And the last thing is that for many use cases around traffic differentiation, so if you look at enterprise or firewall whitelist, there is not much controversy. There is like some sort of like consensus that yes, the person that runs this network can dictate the terms that other people connect to. And so we see a lot of the use cases there, where again, you need to have this concept of application signatures and it becomes harder to operate, but this is not controversial. So I think it's the elephant in the room, and we try to make it very visible and put lights on them, because this is what we're trying to solve. It's one of the main drivers for what we're doing.
Agreed. I mean, fundamentally, what you're proposing is essentially a mechanism, right? And you basically abstracted the policy layer away. It's a separation of the policy layer. How that gets figured out, it's how that gets figured out. And as you point out,
I think we are going one step further. We feel that it's not enough, to just give a low-level mechanism and wash your hands. You have to implement the workflows that can guarantee that things are working as they're working, right? People are thinking about, you have this mechanism that it can be abused. So I think you need to build a stack. You need to build an ecosystem and an understanding on how the different entities coordinate with each other that can meet the requirements that are being meant here. Yes, network tokens is a mechanism, but if we stop at just network tokens is not going to be enough as a community. We need to define the OAuth equivalents, etc.
Agreed, yeah, because all you have is network tokens is the JWT, right? Yeah. And without the OAuth framework, it doesn't add value. But what you use the framework for, that's open. And as you point out, there's safe areas you can start with to demonstrate the use of it that everyone agrees with. And then the more complicated ones, we can increment our way there.
Exactly.
But very nice. No, nice, elegant framework. Appreciate it. So with that, I'd like to thank you, Yiannis, for the time today. That was
thank you very much for the opportunity.
Very good. All right, so with that, thank you, audience, for being with us in the ONS 5G event, and hope you enjoyed it. And there are many more sessions available to you in recording, so do check them out.
Thank you.